Hello, welcome everyone. We're excited you're joining us for today's webinar titled Improve Insights of Grid Performance with Data Analytics. Presenting today's webinar is Giovanni Polizzi, Director for Digital Energy Solutions at Minsight ACS. Giovanni is an experienced energy industry professional with a degree in aerospace engineering and a postgraduate diploma in renewable energy technology. He's an energy enthusiast, collaborating with the energy sector to shape the utilities of the future through digital transformation and application of the IoT and the blockchain. He has consulted internationally for IT systems, smart grids, transactive energy, industrial IoT for utilities, distributed energy resources, and conventional power generation. Assisting Giovanni with the webinar today is John Groders. John is the Business Development Director for Grid Innovation at Minsight ACS. Just some housekeeping before we dive in. This webinar is being recorded, so all participants are on mute. Chat for this webinar is disabled. With the increase of Zoom usage and everybody still working from home, there could be some technical issues. Should that happen, we will work to resolve those as quickly as possible. We should give you a pretty good overview in about 30 minutes, which should leave plenty of time for questions. So if you do have any questions, we encourage you to use the Q&A button at the bottom of your screen, and we'll get to those questions at the end of this presentation. That's all I've got. So Giovanni and John, if you're ready, let's jump into it.
All right, thank you. Thank you, Delana. So this is John Groders. I'm going to just give you a quick overview for those of you that aren't familiar with ACS or now branded Minsight ACS. So if you aren't aware, Advanced Control Systems, or ACS, has been around for quite some time. We have 40 plus years as an operational technology provider specifically for the utility industry. Much of that is involved around RTU and SCADA systems, but we were also one of the earliest in distribution management and automation, including self-healing networks as early as the early 2000s. Then in 2005, we released our outage management system, our OMS, which completed our entire ADMS platform that all utilize the same real-time database. Then in the 2010s, we released a standalone distribution automation platform that works with any other OT system. It's field proven at many utilities, and that includes running Flizzr on over 900 plus distribution feeders at Georgia Power. Then in 2018, ACS was acquired by Indra, when Indra is a global technology vendor for both services and solutions. So Indra is a over $3 billion a year revenue company, employs nearly 50,000 folks, and they spend annually over $225 million in R&D. As you can see here, Indra is organized into two unique business lines and within 6 different industry sectors. So the Indra brand name covers the traffic transportation as well as the defense sectors. And then as you see here, Minsight ACS is part of the Minsight division and under the energy and industry sector. In that Minsight division, there's also the financial, telecom, and public sector and health, all of which can leverage like technologies across different sectors. So Minsight ACS covers the entire utility vertical from generation down to customer with one of the most complete IT/OT suite of capabilities in the industry. As utilities embark on what everyone's calling the digital transformation journey, data becomes the lifeblood, and Minsight ACS has vast capability of ingesting that data from many different sources throughout the utility and organizing and analyzing that data in a way to increase efficiency, effectiveness of the utility. Much of this is going to be discussed throughout today's webinar. As far as investment plan and kind of where we're seeing the industry going and providing solutions for it, we have a few different key points here. So under platform and analytics, it's certainly a focus of today's discussion. How can we improve the consumption and utilization of data? Under customer and user experience, certainly a focus for every utility. How can they? So we were looking to provide better tools for them to achieve those efforts. Regarding distributed markets, DER and DER management is becoming a priority, and Minsight ACS is uniquely positioned to respond to those needs with background in operational technology as well as field-proven edge computing and distributed control capabilities. Under asset management, as utilities are moving more towards performance-based asset management, analytics become very critical and to the forefront to be able to do that. We also support mobility as we get down to the individual workers and being able to do more with workforce management. And finally is regarding IT-OT integration. Certainly that's a buzzword in the industry, but Minsight ACS is truly the culmination of the IT-OT culmination. So with that, I'm going to turn it over to my colleague, Giovanni Polizzi, and he can take it from here.
Thank you very much, John. Thanks to all the participants. We know we have a lot of people participating in this webinar, so we are really excited to present you with our idea and our solutions about data analytics. In particular, we're talking about data analytics related with technical data in the utilities. So what we are aware that data is becoming an ever more important asset in pretty much any sector. In particular, utilities collect data from numerous sources and in several ways. Data collection is definitely not an issue in utility in terms of richness of sources and in volumes. There are problems, however, when we move along the data processing journey. What we're seeing here is what we may find in many utilities, many organizations: heterogeneity of sources and supports, heterogeneity of data sources, temporality of data, granularity, accessibility, interoperability. These are all issues we have all heard abundantly in our professional lives. Yet these problems are a reality for many utilities, if not all utilities, at least at some stage. So the presence of tens of complex spreadsheets is a burden any data analyst has to face at some stage. Department-specific information held on personal computers with desktop application that only run, very few people can run, are often associated to enterprise-wide reports. Someone basically generates report for the entire company, and then these reports are spreadsheet which can be then manually changed, and sometimes information is actually it's contradictory in the company. Data warehouse projects have tried in the past to break this chain by taking important data to specifically design databases. Although great value was created for companies, data warehouse would normally not manage technical data, which was then left to departmental application and spreadsheets. Lastly, technical data is normally managed by a few, but requested by a lot. So engineering departments and SCADA administrators have become the data provider of many more, to the point that they basically become the data sources. Another topic is, of course, the administration of this. When we have corporate system, have some administration tools. Data warehouse have some other administration tools. Sometimes users and their access to data is not homogeneous across the company. So, pillars on which we build data analytics. Our data analytics is built on 4 pillars. First, utilities need to collect data from several sources, so not only one system. The sources are generally heterogeneous in data formats, in interfaces, in granularity, in volume, and in origin. Some data needs to be analyzed as it is collected, for example, to assign a quality check or to be rejected. Some other may need to be aggregated, averaged, or to go through conditional steps to trigger control points. Data is taken as raw, and once enriched, is stored as a new value. What do we mean by this? A data signal of voltage and current at the transformer becomes relevant data for an asset and maintenance application, or a measure of energy at a substation becomes a relevant parameter for an application measuring feeder performances. A voltage at a point in the feeder becomes relevant information for voltage monitoring application. So all of the above can feed mathematical models to forecast those or some measure with a full range of working conditions. They can also be used to inform over and over an underlying problem, for example, which would not be spotted if we only look at one of the measures at the same time, at one time. So the analytics becomes very important in a company because it's used to improve maintenance, to improve system performances, and to improve power delivery. The findings of the data analytics can then encourage deployment of upgrades in networks and support quantitatively the choices made by the company. And I pass the word now to John again for a poll question.
Yeah, so in trying to get a little bit more interaction with the attendees and understand kind of where you guys are all at, our first poll question is, which system do you access most for data currently? So is that your SCADA system, outage management system, AMI or metering, asset management, historian or data warehouse, or other, or none of these that we've mentioned? So you should see a poll question pop up, and we'll give you guys a little bit of time to answer that, and then we'll share the results.
Answers are still rolling in, so I'm just waiting on them to slow down a bit. All right, that looks like about it. I'm going to show you guys the results now.
Okay, so it looks like SCADA is the, as kind of expected, SCADA certainly is the system that is accessed most, but it's a pretty wide range. So it looks like we have a pretty diverse audience. So with that, Giovanni, I'll turn it back over to you.
Okay, thank you very much. And thanks to all for answering those questions. Okay, so if we look at a utility, and we basically have here we represented what the systems could be in a utility. We start from the bottom and we go up in this slide. So the bottom part is, of course, representing the field. It's representing the meters, representing the distribution network monitoring and control, so the feeder automation, for example. It's also representing the field operations that are run in the utility. On top of that, we have the two networks, so meter data network to bring back metering data to the company, and then the IoT data network for those who have built it already to bring back data from physical devices in the network. On the other side, we have the more traditional communication channel like video automation, substations, RTU, and IED for protection and control. These are normally connected to SCADA and OMS, and that information is already treated at SCADA level or the OMS level, and then fed as information to systems that are on a higher level. Of course, in the higher level, we have the smart metering, customer management systems, and grid and asset management for operation, but also for the maintenance of the grid. And then we have the grid operations in a more general sense, so data that information that is relative to every single operation that is run in a grid. On the side, here on the right, we have complementary solutions and services, which are basically systems that provide services and are used by the other application, are used across the other application. For example, the GIS is a typical system that will provide information, or that is which other application rely on. On top of that, that's where we put the data analytics. So we have to be able to bring up all the data from different systems and be able to analyze that data. So how do we do that? Is basically done through a layer, different layer. So if we start from the bottom, we see in this slide that not only system but also field provide data to the intelligence. Starting from the bottom, we have the data sources, meaning the system that provide data. So this system already manage their own data, and normally they would have already reporting, for example. They would already have a kind of intelligence, but it's very sectorial, so it's very vertical on those systems. On top of that, we normally put the industrial IoT platform. That's where the industrial IoT platform allows data from the field devices and physical assets to be brought up into this analytic platform. The first layer of the analytics platform is the operational intelligence. This is the layer of analytics for technical data. Data from the field, data from the SCADA, data from a system which are more operational than transactional. Other layers of intelligence blend technical data with data from enterprise system. So that's where we get the other vertical analytics layer, so the other vertical intelligence. When we talk about asset intelligence, to us, this is related to performance of asset. Health index, for example, it's one of those. Grid intelligence is related to grid operation, typical SAIDI, SAIFI, but also with workforce management, with project management, such as extension of augmentation of network, with the use of crew, for example, the efficiency in the use of crews. That will be the grid intelligence. Customer intelligence, when we use technical data for customer intelligence, we are referring to the way service is provided to customer. So such as time of response for service order, for example, quality of power supply, frequency and duration of outages, customer by customer. That's an idea. Of course, we also have reporting in customer system, but that's pretty much on the, for example, on the billing side, on the contract. What we're trying to figure out here is how we provide a technical service to customer by using customer data. And then the meter intelligence is, of course, everything but the consumption data, so which is typically used in MDM systems for billing reasons. When we talk about meter intelligence, analyzing other information that comes from the smart meters. On top of the comprehensive performance indicators, the first layer, then we have the proactive layer. This is where the system, the mathematical models help to understand something that is going to happen, or to understand the models and how to improve them. What we're going to talk today about is the operation intelligence. So it's that flexible field data analytics. Again, we started to see this, and we see a very fragmented data analytics flow, and we want to transform this into what can be done in a platform. So this is a platform. This is the way you see we're trying to keep the same color. So we still have the data source, we still have the collect layer, the process layer, the storage and contextualization of information, the analysis and the visualization, and we still have the administration component. So what are these components? What do they do? What's the information that they manage? So this is the collect part is where we are able to stream in data either from real-time information or from for example, from files, from FTP side, right? We have a number of industrial protocols. Because we have to bring in information directly from the field, from system, for example, DNP. We have MQTT, so we have a number of protocol which are already there. Bear in mind that we are also able, this platform, although it's not shown, this platform is also able to bring data from IoT gateways, which are deployed directly in the field, and where we can actually process data directly in the field. What we mean by processing data, again, data is still can be streamed in real time, so it's processed in real time for immediate action, triggering alerts, triggering warnings, doing data filtering, automate actions like, for example, averages, comparison with the moving average of a particular data signal. In this case, we have also a rules engine for data validation to notify other stakeholders, for example, even before data is stored, and to aggregate data. For example, if we want to have, we have a number of information from different data sources, we want to have an aggregated information. That's where the data processing part is done. That part can also be deployed in the field through IoT gateways. So we can also put those control in the data in the field without having to bring it back to a centralized application. The next step is the organization of data. So the storage and the contextualization of data. And as I was saying before in the other, or during the other slide, a signal is a signal, but it becomes information when we have the point of view of another application. For example, maintenance, for example, a customer information that becomes our voltage regulation information. The other one is learn. So learn, when we identify learn the analytics part, that's where we start to compare, for example, signal with mathematical models to try to understand where there is a deviation from the expected, and then we can study what the deviation from the expected value are. Again, in this case, we have multiple data analysis languages that can be deployed, that can be used in this analytics model. And then the other part, the visualization, we call improve. So visualization, reporting, notification. Once we learn something, we try to visualize, we try to show how the system is improved. Our performances have improved. Notification are triggered based on, for example, self-defined formulas or data processing algorithms. So, and at the end of this, so on the bottom part, we see the administration. So every single module that is in this platform is administered from one single entry point. Every user, every interface, even the databases, it's actually abstract the entire platform from the underlying database that we would use. There's a number of technical solutions to do that. But basically, the idea is to be able to wrap all these elements under one single platform. Of course, the market prepares for each one of these elements. The market's already available with the number of other solutions. What we have tried is to have everything in just one place and trying to simplify the use of this single modules. And here we have another poll question that I'll pass the word to John to explain.
Okay, so for the second poll question, of the following use cases below, which would be your best or your first priority for a data analytics platform like we're discussing? So we have the system performance from SCADA data, active monitoring and responsiveness of your distribution assets, feeder load and DER forecasting, feeder voltage profile leveraging your metering data, or a different one other than this use case. So a poll question should pop up and we'll give you a few minutes or a few seconds to respond.
I feel like we need the Jeopardy theme song going while this is happening. All right, slowing down a bit. I'm going to stop the polling. Oh, a couple last minute ones. All right, here we go. And here's your results.
Okay, so looks like we kind of match our previous, and it looks like the biggest use case would be analyzing system performance utilizing SCADA data. So probably obviously a lot of operational folks on the webinar today. So with that, we'll advance, and Gio, you can continue.
Thank you very much. So the first one was SCADA data, and the second one was, number two, so active monitoring responsive distribution assets. These are two very good use cases that we are seeing a growing interest in. And so first of all, we talked about bringing data, so bringing data from different sources. So what would this look like in reality? For example, here's an organization of data. So every single data that we bring back from the field is associated to an asset. The level of the asset can be as extended as required. We've done an example here. Of course, we have a general asset is general company, for example, and then we have a substation, a transformer, and then circuit, and below the circuit, all the ID connected to the circuit, and even lower level. Depends on how we want to organize that information, those signals. Bear in mind, we're not only talking about signal, we're also talking about the possibility to associate static information to any asset. For example, the manufacturer, the model, the year of installation, and the last maintenance visit that has been done on those assets. Latitude and longitude, so the GPS coordinates, because we may want to analyze that information by manufacturer, for example, by model, or we want to analyze information by geographic area. So that's the first way in which we have thought to organize information. This is a navigation tree. We normally have a master, and then we create virtual ones, according, for example, to an organization. If you have a part of your company is just concerned about a number of or a portion of the network, when they access the platform, they don't have to see the entire network. They would just see the network that is of their particular interest. For example, a contractor, a crew that has to analyze data in that part, or a member of a cooperative that just need to analyze information about their own network. So this is why we thought about it, a general master tree and then a subsequent virtual ones. Information is deployed. Of course, we're seeing here a dashboard. It is an interactive advanced dashboard. Information is plotted as trend, it's geographic, it's with pie chart, for example, or in tabular form. And up there, for example, in the image on the left, you see a tree, which is not the entire tree that we were seeing before, just a portion of the tree. So we're looking at just substation. We can select substation by selecting one of the substation up there in the tree or directly in the geographic information. Again, this is the way we imagine a dashboard. A dashboard can also be totally different because the interest is different information. Dashboard are totally configurable. So this, for example, is the same information but seen in the total tabular form. And here we get the alarms. We get the value which are out of the expected value. That's why we get different colors: the green and the red and the yellow. Again, we have system data, and then we have specific data for what particular element that we have selected. We can go even lower. We can go, for example, in the feeder. Here we're comparing a monthly reading, and of course the data is particularly confused in this because we wanted to show the variability of the potential of visualization of the tools that we're using. In this case, we're seeing a weekly averaged value of the feeder against monthly data along, for example, a substation, right? Another thing, we are bringing back data directly from the field. We are analyzing, in this case, a battery. All these are signals, and we decided, for example, to activate or disactivate the triggers, like controls, to have then alarms triggered by the monitoring of the signal. This is a dashboard that is much less advanced. Let's say it's a simple dashboard. This is a dashboard that any user can configure. For example, rather than using an Excel file and doing these graphs, it can use directly a dashboard, create his own dashboard with the most common data that he analyzes, and then decide to use this rather than the report. But of course, maybe he needs a report anyway, because he needs to prepare a report to be sent. This report is to be printed in a PDF and then sent through email. So again, the reporting is here. So what we're seeing here, of course, is the user interface. So it's the visualization, the notification, and the reporting part of the platform. But what's beyond? We talked about putting data from different systems. So what would that look like? So how can we leverage an integrated analytics platform? What we're seeing here is, for example, we brought in data under the same platform, data from the OMS, so data about the outages. Of course, this is already available in an OMS system, for example. But the idea is that we can bring this data here and then join this data with other information. For example, the average distance, the average distance of the crew, number of miles, or the average restoration time. Or we can see the effectiveness of maintenance visits. We have a corrective, preventative, for example, and predictive, and with different values. Or we can take the project. How are we using the budget that we have allocated for a project, for materials, for services, for transportation, for labor, for example, internal or external crews? How much of the cost has been planned, has been required modification, or has been how much of the cost has been inspected? Sorry, again, here we have on the side we have a geographic organization of the information, because normally cost center are organized geographically. And here we have a crew, the crew distances, for example, how many, the availability of crew during the day. Of course, a workforce management system has already got this information. The ability to have everything together in the same platform under the same tool is what we are trying to leverage here, and to mix data together from different systems. And beyond that is, for example, the using forecasting information and overlaying that forecast information on a geographic information system. What we're seeing here, for example, is the area occupied by the water surface in a basin, according to forecasted level of depth of the basin. Right. Of course, the white one is the least deep, and the dark blue one is the most deep. Imagine what you can, for example, do if you want to understand what an area which could be flooded under heavy rains, and which are the substations that will be affected by that, or which customer will be affected by that. Where do you have to deploy the crews to restore energy in the shortest time? Because I can expect that area probably is going to be flooded. The other one that we're seeing on the right, on the high right, is the analysis of images. Again, the same platform can analyze images, can run algorithm to analyze images, and in this case, can be very useful. For example, to stream images into the system. In, for example, an area which is the access to a substation, or an area where you're running maintenance, and you want to be sure that nobody is in that area before running some of the operations, then you can stream images. An image at the end of the day is data, and this data can be analyzed through the same platform, and data, people can be detected, animals can be detected, just the occupancy of a passage can be detected directly from the platform and alert a control center before any operation is run. So again, we started from a very fragmented data analysis, very linked to the data source, rather than being able to blend data from different data sources and through different applications. And we moved into a platform that is able to blend that data and give information very broadly about the operation of the company and across different departments. And we ask you to answer one more question. So John, please.
Yeah, so our last poll question, we're curious kind of see where everybody's at with potentially looking at systems and data analytics platforms like this. So the last question is, when might your utility be interested in implementing a data analytics platform like we discussed in today's webinar? So is it very soon, as much as this year, maybe within the next couple years, or further down the road? Or the last one, no interest of this type of platform, at least not currently. So with that, we'll activate the poll and give you a little bit of time to respond. And while you're responding, also, it looks like we do have some questions coming in. So certainly feel free. We're going to stick around and answer quite a few questions. So get those in as you can.
All right, looks like we've got a little pause here. I'm going to end the polling and share those results.
Okay, so it looks like it's kind of in the midterm where most of the folks on, maybe within the next couple years and maybe further down the road. So thanks for sharing that with us. And with that, we will jump into answering some of the questions that are coming in. And again, if we don't get to your questions, we will certainly do our best to reach out to you and try to answer them offline if possible. So Giovanni, the first question we have in for you is, how long would a project take to implement a data analytics platform like this, and where should we start?
Yeah, thanks, John. That's a very good question. So yeah, we've been asked that a number of times. Of course, as we've seen the interest of our audiences, for example, for data coming from the SCADA data, and that would actually be the place where we would start. SCADA is very rich in data. There's a utility normally find challenging downloading data from SCADA, or even analyzing a significant number of real-time information. For example, to when a visualization or a signal is lost, for example, from the field, trying to monitor that, or just real-time data to trigger alarms or to trigger a warning. So our first approach would be to link the data coming from the SCADA and to to give visibility of that data. Of course, there's a part, initial part, which we have to decide how that navigation tree will be built, and there's an agreement with the utility. And then next step, okay, let's bring in back data from the SCADA. Sometimes we can even bring data back from the field that is not in the SCADA. So we all know that ID normally produce a lot of relevant information, which not always is brought back to the SCADA. So we can go down in the field with IoT devices, for example, and bring back that information into this. A basic integration with the SCADA would normally last in the project between 2 and 3 months to bring back and to really visualize the very like data that is already stored, for example, in Historian. That would probably be around 3 months. Then bringing back data from the field, it all depends how the data is already available. If it's not in the SCADA, where is it going? Sometimes it's going into other Historian, into other department databases. Sometimes it's through data logger, so it's downloaded once a week maybe. So we would have to see that kind of data. But again, this is not a project that will last years. It's pretty straightforward and to give already visibility. Once the company, once the user access the platform and start to play with the platform, then they will be the ones proposing new dashboards, new kind of analysis. In that case, would be probably we will see what the rest of analysis can be.
Okay, very good. Another question is, will these slides be made available? We will provide all of you a link to a copy of this recording. So if you did need to go back and go back through any of it, and also if you wanted to share it with someone else within your organization, we will provide that link for you. Another question for you, Giovanni. Where does the ESB fall in the new operational intelligence platform?
That will be, for example, one of the channels where we can bring data in. If we were to use, if the company already has an ESB, would have to decide which data can be brought back in from there, and it would of course enrich the database in the application. We would have to see again. We of course have the interface to bring back data from there, and to see if there'll probably be more data from other systems, so absolutely relevant would not come maybe from the field. So again, normally there is a number of web services, and we will use those web services to bring back data from there.
Okay. Very good. Also, I just wanted to point out, so we do have a slide showing you the sales contact information for all the different sales directors, depending on what region you're in, or if you just have some general inquiries, you can certainly email those at sales@acspower.com. Giovanni, another question. A platform like this looks pretty flexible. How autonomous can the utility be after this has been delivered?
This is, yes, so what we are seeing is that we'd have to probably to analyze two level. So one is, what can the user do? How flexible is the platform from the user? Apart from the navigation, which is pretty user friendly, the other thing is we've seen one of the dashboards that could be easily created by a user, and I think that we probably one day of training, any user can create his own dashboard by using the widgets which are already available, like pie chart, like trends, tabular forms, for example. He can create his own dashboard, and that would probably cover his most routine analysis, very, very specific on his needs. Different is the more interactive dashboard. So we also saw those ones. In that case, there is some programming to do. Again, it's not a real coding. It's more like going a bit under the user interface and try to link components, like you link a navigation tree to the data coming from the graph. So you have to query data according to what has been selected. There is some work to do, and that normally is what we would train the administrator to do. So administrator has got an administration role for the interfaces, but also, for example, to create a new interactive dashboard. An analyst programmer with a couple of days of training and then maybe a week of follow-up will probably be pretty autonomous in creating those dashboards that we have seen. So the other thing is that we can, of course, provide services on the platform to develop this specific dashboard. Same thing for the reports. Reports are an administration role normally. We think that an administrator role is the right person to decide which reports, try to not duplicate reports in the reporting tool. And again, an analyst programmer with a couple of days of training and then maybe a week of support will be fully autonomous in developing reports.
Okay, very good. Another question. Can calculations and quality checks be made on ingested data before it is stored?
Yes, that's one of the things that the stream, we use a component that's called Node-RED, which is open source. By the way, the entire platform that we use is all based on open source code. So we use that, and actually can be pretty complex, the calculation that is done on stream data before it's actually stored. And that's one of the things that we have built in the data processing tool. Bear in mind that this can also be done in the field. So through one of the edge components, for example, we can deploy those as container. We can deploy that pre-processing tool in a component in the IoT gateways, for example, and avoiding, for example, to bring back data to the centralized platform because it's not relevant at the moment. And we only bring data if data is above or below a threshold, or I know a number of if conditions, for example, then that would generate data being sent back. So there's also quite an optimization of data traffic from the field in case of, for example, the communication is weak or it's of reduced bandwidth.
Okay, so that is all the questions we have so far. So certainly if any of you have questions afterwards, feel free to reach out to any of your sales directors or that general inquiry. But with that, I'll turn it over to Delana to wrap us up.
Cool. Thanks, John. Thanks, Giovanni. Thanks, everybody, for joining us. I do want to remind you that in 2 weeks, on June 17th, same time, 3:30 Eastern, we've got another great webinar for you on showcasing peak shaving and load flexibility utilizing DER. So if that's something you might be interested in, make sure you hit up the events page of our website and get registered for that one. And we'll see you in 2 weeks. Thanks for joining us. Bye.